Hey guys, Andrew from PracticalMaker.com here. So again, we're looking at the Arduino board today, as well as the MacroDuino web app. So we're just going to go over kind of the setup that we have right now. There is a orange LED hooked up to pin 9, a green LED hooked up to pin 7. There is a DS18B20 temp sensor hooked up. And we're also hooked into my home network via the Ethernet shield. Now I should mention that now that the Ethernet interface is finished, I was actually thinking today that it's not going to be very difficult to implement a Wi-Fi solution or actually a GSM solution since the data that you send to it is always the same. It doesn't matter what interface that you use. For example, to turn this pin on, you send 4/9/1, and over the Ethernet you send the IP address /4/9/1. So it's basically a matter of grabbing the data from the Wi-Fi shield or the GSM shield and passing it to the control function. But that's not what we're doing today. Today we're looking at the MacroDuino web app. So you can see here, it's kind of, well, it's opening right now. This is hosted on PracticalMaker.com, and you can see we've got a whole bunch of things that you can do: status, digital control, digital macros. We're going to go through them one by one. So we're going to start at settings, and so you can see we have a couple options here. You can add your address, select the Arduino that you're working with, so you can actually have multiple Arduinos on the same network. And what this does is on the status screen, it will only show you statuses for that IP address. So let's say we want to add an external. This actually does work over the internet, kind of. I'm having a problem with my I can't get it to work on the 3G, but I can get it to work on the Wi-Fi using an external address. So I'm thinking that has to do something with the DNS of Rogers or something. Anyways, we're going to add that, dynDNS.org. And I've actually set it up port 9099 to forward to the Arduino port 80. And so we're going to save this. It says settings saved, and then it shows up there. And the other thing right here, I told you we had a one-wire temperature sensor hooked up. So right now we're going to select the local network address. Now it's very important that you don't include the HTTP in here, because I add it automatically in the file. So we're going to discover one-wire addresses, and we're going to go home. Now the bread and butter is the status screen. I'll just delete that. Okay, the status screen can show you right now the status of a digital pin, analog pin, a pH reading. So basically that reads a analog pin and does the pH calculation on it, and then it can also return the value of the temperature sensor, DS18B20 for now. So we're going to add a DS18B20 temp sensor. Since I only have one, it's temp sensor 0. Since I'm in the office right now, I'm going to call it, whoops, that'll autocorrect, maybe not, office temp. And we're going to click save, and the success flashed up. While we're here, let's take a pH reading of analog pin 3. And just for the heck of it, we're going to call it tank pH. Done. Save that. Success. Back. And now you can see that it's going to load office temp right now, 75.65 degrees Fahrenheit. pH. I don't have a pH probe hooked up to it. My finger is on the temp sensor right now, so during the next refresh, it'll probably be north of 80 degrees. Now we have 76, so it's going up. It's actually kind of cold in here. There we go, 77.55. And so basically, instead of having to go over to your Arduino, you just open this app up, and it'll tell you the status. Stability has been greatly improved. I've left it running for the Ethernet portion of it for 2 days now, and it hasn't crashed. So we're going to go back. This is the best part of it, in my opinion, the status. So we're going to go, I showed you digital control before in another video, so we're going to, there's actually been an addition, do pin 9. So pin 9 is the orange one, and we'll turn it on. Now you can see whenever I hit it, it pops up. I actually used JGrowl. If it's a success, it'll pop up. There's a problem with it. If the Ethernet is not responding, it'll time out and it won't send anything back. So if you don't see this message, then you know that something's wrong. Now the other cool thing, there's a slider that sets PWM values, which I think is cool. And then you can do pin mode, output, input, we'll turn it off, and output again. Next we have digital macros. So these are basically macro number, so you're going to have to keep track of the number of macros that you're using. Start at 0, so we'll say macro 0. Next, let's watch pin 0 and 2. Let's watch pin 5. Watch date. We'll watch it for a low. Output pin 9, and we'll turn output pin. So if pin 5 goes low, turn pin 9 off. And output time on is basically going to be used for things like well, in the aquarium anyways, it's going to be used for things like dosing pumps. So if you get a reading, blah, turn pin 9 on for 5 seconds. So we're going to actually go done and save this macro, and you can see the success. And we actually have to go in and set pin 5 as an input. So we're going to do that right now. Alright, so pin 5 is now an input, and we're going to turn pin 9 on. So right now, actually, pin 5 is floating because it's not actually connected to anything. So you can see that when I turn it on, because pin 5 is floating, and so when it reads it, it's a low, it goes off. Okay, so we'll set up another macro. You actually need 2 macros to actually do anything. So what we're going to do is we're going to go macro number 1. Watch pin 5 for a high. Turn pin 9 on. Now, important, the output action can be anywhere from 0 to 255. 0 and 1 are off and on respectively. Anything higher than that is a PWM value. Okay, so now that we've saved that, if we take pin 5 and plug it into high, so just 5 volts, you'll see it turn on. And if we pull it out, goes back off. So that's definitely useful. Next thing we have analog macros. So let's say we're on macro number 2 right now. So let's watch analog pin. You can only do 0 to 4 with the board because 4 and 5, or sorry, 0 to 3, 4 and 5 are used for I2C. So let's watch pin 0 for 500, and so you can see here 1 equals less than, 2 equals greater than, 3 equals 2. So let's say greater than 500. We're going to use a different pin. We're going to use pin 6. Turn pin 6 on, and output time on 0, so it just turns it on. So we'll save that. Oops, did it save that? Oh, not all of them pop up with the success yet. Alright, so pin 0 goes high. So I guess we have a problem with the analog macro set. And that would be it. Greater than, less than, or equal to needs to be 2 instead of 500. So now if we do this, well, I guess we have a problem. You know, not everything's perfect, I guess, but it will be. So we'll move on. We have DS18B20 macros. So we're on macro number 3. Sensor number. So this is going to be a bit tricky because when you discover one-wire devices, it saves all the addresses in the EEPROM. And so the easiest way to figure out which sensor you're working with is just add it to the status screen and then put your finger on it to figure out which one is moving. And so we only have one hooked up right now, so that's sensor 0. And let's say greater than, we want it to be a greater than, let's say 81 degrees. Turn pin 6, oh, you know what I bet you it is? Pin 6 isn't an output yet. Output action as a 1. So we're going to save this and go back to digital control and set pin 6 as an output. So now we'll unhook this part and we're going to go into status so you can watch the values rise. So we're at 77.9. $81.26. I guess it should have turned on. The problem being I'm not in pin 6. Alright, so the macros are working. I had the green LED in the wrong socket. So we're going to set up one more macro so you can see how to turn things on and off based on temperature. So we're going to go macro number 4, sensor 0, 1 is less than, so let's say less than 7,900. So you have to send it without a decimal. So 7,900 is actually 79.00 degrees. And output action of 0, save. Okay, now you can see it goes off, and here's the temperature sensor. I'm going to put my thumb on it, and it will come back on in a second. And I'm going to let it off, and it'll go back off. Might take a There we go. Okay, so it just went under 79 degrees, so it turned off. So we're going to put this in. So this is the analog macro. Above 500, turn it on. And actually we have a conflicting measurement, because our temperature sensor is saying it's under 79 degrees, so turn off, but this macro is saying, the analog macro is saying, well, it's above 500, so turn it on. So it's turning it on and then turning it back off as the macros run. So let's take this out and we'll put it in pin 5. So that's our macro for the digital. So we basically say, oh yeah, it's high, turn it on, low, turn it off. So we're all good. Now we'll move on to the DS1307. You can only set it. You can't actually get the time back yet. But you can see here, it's really easy to set. You set hour, minute, second, day, day of week, and month, and year. And you just click save and it will set the real-time clock for you. And DS1307 macros are the same. You basically give it a macro number: hour start, minute stop, hour start, minute, hour stop, minute stop, output pin and output action, and it will run that macro for that period of time. So let's say macro 5. Hour start 16 is 1800 hours. Minute 0. You know what? We'll do 27 maybe. 27. Hour stop 1800. Minute stop 29. Output pin 6. And output action 1. Actually, you know what? Yeah, we'll do that. We'll save that. And so you can see it just came on. Mostly because it turned 27 right now. And, you know, it'll stay on until it reaches 6:29. Make sure you set these in 24-hour time, because well, it's kind of difficult to make it so that AM or PM, and figuring out 24-hour time isn't that difficult. And last, well, there's a couple things left. LCD setup, not really implemented yet, but if you've been following, you know that I've set it up so that you can basically display whatever you want on the LCD wherever you want. Right now you can display any of 3 temperature sensor readings, pH, and time. Other things will definitely be coming soon. And we have read values. Now this is really cool. So let's say if I want to read the value of digital pin 5. So I say that value for pin 5 is 0. So right now it's low. And value, let's say we want to read an analog pin. Analog pin 0. Now they're floating right now, so it's going to give a weird value. So 446. And you want to get the temperature. Now this is also another way you could figure out which temperature sensor you're using. So temperature sensor 0, get the temperature. Value for sensor 0 is 75.97 degrees. And so basically this is just for one-off readings. If you want to keep track of something, put it in the status screen. And that's pretty much it. There's a reset, which basically resets all the macros. Not really recommended. There's room to store 40. Right now we've used 5 I guess. And if you reset all of them, you'll lose everything. So make sure just to keep track, and hopefully in the future you'll be able to read back the macros and figure out, you know, macro 0 is doing blah, and then you'll be able to edit it. But right now, you know, this is just a first release of something that works, well, pretty well. So what else do we have? I think that's pretty much it. This will work. There's a couple cool things about this. The reason it works, we use jQuery JSON P to get that. So we send it, and then I made the Arduino send back a valid JSON P string, so we can actually do the cross-domain. Okay, the real-time clock macro just turned it off, and so now we'll be running with analog macros. If they float above, it will trigger that. The JSON P stuff allows us, this is hosted on practicalmaker.com, yet I'm controlling stuff on my local network, and so that's what allows that. This will only work with a WebKit based browser. So things like Google Chrome, Safari, I don't know if Opera uses Google Chrome, but, or sorry, not Google, if Opera uses WebKit. Basically, any iPhone or Android phone, you're fine. As for Windows phones, I'm not sure, I have no idea, I've never used one. But it needs to support the HTML, well, not the spec, but the SQLite databases. So, anyways, I hope you enjoyed it. I know the video ran quite long, but I'm really excited, and I hope you're excited about the potentials of this too.